This is a question from the final of April 2019. It asks us to show that the integral from 0 to pi over 2 of f of cosine of x dx equals the integral from 0 to pi over 2 of f of sine of x dx. And at first it looks a little bit daunting, it looks a little bit intimidating because we have some sort of function, it's the same on both sides, but we don't know what it is. And then what we have inside of it is different. Cosine of x and sine of x, well, these are two complementary but very different things. So what's going on here? Let's just take a look at our sine and cosine functions along the interval that we care about. Let's zoom in a little bit right there. I want you to notice that our sine function that we have in here in green along the interval from 0 to pi over 2 is just a mirror image of our cosine function from 0 to pi over 2. So if you were to just take these and flip them around, swap them around, they would just, the area underneath each one would fit perfectly. So you can only imagine if you just built some sort of function off of this as an input that, well, I'll go ahead and show you. Let's say that we have the area under the under this curve, which could be represented by f of sine of x, and the area under this curve, which could be represented by f of cosine of x, or the integral of f of cosine of x. These are also going to be mirror images of one another, because for every input you have an equal input into the function over here, just going in the opposite direction. So in other words, area A is going to be equal to area B. And if you want a little bit more formal proof of this, let's just take a look at, let me zoom out just a bit. Let's take a look at this expression, which we proved in a previous video, that the integral from 0 to a of f of x dx is equal to the integral from 0 to a of f of a minus x dx. And just like in a previous video, we showed that this is true when we have these sort of overlapping mirror image functions. So in other words, just doing a little bit of mirror matching here, our a is pi over 2, our function is f of cosine of x, and we're just plugging a minus x, or pi over 2 minus x, into that and saying that this is equal. Well, just by our trig identities, we can swap the pi over 2 and the x around, just by virtue of the cosine function being an even function about the origin. So f of cosine of pi over 2 minus x is just the same as f of cosine of x minus pi over 2. And when you plug it into the integral, that's going to be also the same. But cosine of x minus pi over 2 is just equal to sine of x, which is, so we're back where we started. So in other words, we have just proven, both geometrically and notationally, that the integral from 0 to pi over 2 of f of cosine of x dx is equal to the integral from 0 to pi over 2 of f of sine of x dx. And again, these are just going to be mirror images of one another that happen to have the same surface area underneath.